Friends, let's talk about something vital: water. It covers most of our planet, but only a tiny fraction is fresh and usable. Most of Earth's water is salty ocean water. The fresh water we rely on is under pressure. Our population keeps growing, but the amount of fresh water stays the same. More people, more farms, more factories, all needing water from the same limited supply. This leads to water scarcity, not enough water for everyone's needs. Some places face years-long droughts, shrinking rivers and dried-up lakes. On top of scarcity, there's water pollution. Factories, farms, and even our homes add chemicals and waste to our water. Polluted water is unsafe for people, animals, and plants. So, we're facing a double challenge: not enough water, and what we have is often dirty. These issues threaten our health, food, environment, and even global stability. But science is about finding solutions. How can we ensure enough clean water for everyone? Let's dive in and find out. Why is treating wastewater so important? If we dump dirty water back into rivers and lakes, it would be a disaster. Polluted water spreads diseases like cholera and typhoid, making people, especially kids, sick. Nature suffers too. Fish can't survive, plants die, and entire ecosystems collapse. Polluting water destroys biodiversity and harms countless species. Treating wastewater protects our limited freshwater resources. If we keep polluting, water scarcity gets even worse. Cleaning wastewater lets us reuse it for irrigation or industry, saving fresh water for drinking. It's about public health, protecting the environment, and ensuring enough water for the future. Treating wastewater gives water a second chance to help, not harm. It's a critical step in living sustainably on Earth. Science in action. For years we relied on big, complex wastewater treatment plants, huge concrete facilities on city edges. They screen out big debris, let solids settle, and use bacteria to break down waste. Some even have a third stage to remove extra pollutants. But these systems are expensive to build and run, using lots of energy and skilled operators. Smaller towns often can't afford them. They also create lots of sludge, which is tough to dispose of. Sometimes, even after treatment, water isn't perfectly clean. Chemicals used in the process can linger, and not all pollutants are removed. So, while conventional treatment works, it's costly and not always sustainable. That's why scientists are searching for more natural, affordable solutions. Is there a better way to clean water? Let's find out. What if we let nature do the work? Wetlands, marshes, swamps, bogs are natural water filters. Scientists thought, why not build our own? Enter constructed wetlands, shallow basins filled with gravel and water-loving plants. Wastewater flows slowly through, and nature's processes clean it up. These systems use plants, microbes, sunlight, and soil to purify water. No heavy machinery needed. They're energy efficient, cost less, and are environmentally friendly. Constructed wetlands can be beautiful, attracting wildlife and boosting biodiversity. They're perfect for communities without resources for big treatment plants. It's ecological engineering, working with nature to solve human problems. Science at its best. How do constructed wetlands clean water? It's a team effort of natural processes. First, as water flows through gravel and plant roots, solids settle out, like a natural filter. Plant roots and gravel trap particles, removing visible mess. Next, bacteria and microorganisms break down organic pollutants, turning them into harmless substances. Some bacteria remove nutrients like nitrogen and phosphorus, preventing water pollution downstream. Plants help too. Their roots provide surfaces for bacteria and move oxygen into the system. Plants can even absorb heavy metals and nutrients, a process called phytoremediation. It's a partnership: plants, microbes, and the environment working together. By the end, much of the pollution is gone. Wetlands turn dirty water into something much cleaner, naturally. That's the magic of nature-based solutions. Constructed wetlands aren't just a cool idea, they're backed by research. At universities like UPC in Spain, scientists build mini-wetlands to test and improve designs. They experiment with different plants, gravel types, and water flow rates. Researchers analyze water before and after treatment to measure effectiveness. There's no one-size-fits-all. The best wetland design depends on local needs and climate. Some wetlands have surface water flow, others flow beneath the gravel. Each has its advantages. Research helps us understand how plants, microbes, and pollutants interact. Scientists discover which bacteria are best at breaking down chemicals. This research turns good ideas into reliable, real-world solutions. Science in action, making a difference for our water. Constructed wetlands are great, but they have challenges, like clogging. Over time, gravel can fill with solids and dead plant material, slowing water flow. Too much incoming gunk or excess microbial growth can block the system. Good design and pre-treatment, removing big solids first, help prevent this. Operators monitor water flow and levels to spot problems early. Letting parts of the wetland rest or flushing with water can clear blockages. Sometimes gravel needs to be replaced, but that's rare with proper care. Ongoing research keeps improving these natural filters for long-term use. Constructed wetlands are perfect for rural areas and small communities. Building a big treatment plant is often too expensive and complex for them. Wetlands can be built with local materials and don't need constant electricity. Local people can be trained to build and maintain them, creating jobs and ownership. These systems are robust, handling changes in wastewater flow and quality. They protect local rivers and groundwater, vital for drinking and farming. Wetlands offer affordable, effective sanitation where it's needed most. They empower communities to manage their own water. That's real water wisdom. Constructed wetlands do more than clean water. They offer bonus benefits. They create habitats for birds, insects, frogs, and more, boosting local biodiversity. Wetlands can cool the air and reduce city heat, thanks to water and plants. They absorb noise, making neighborhoods quieter and more pleasant. Wetlands are great for education. Schools can use them as outdoor classrooms. They can become community parks with walking paths and birdwatching spots. Some communities even harvest wetland plants for crafts or compost. These systems are truly multifunctional, helping people and nature. They're green infrastructure that keeps on giving. Clean water, wildlife, and community benefits, all in one. We've explored water challenges and the power of constructed wetlands, nature's water filters. These green solutions are key to a healthier future for people and the planet. Share what you've learned, spread the word about sustainable water management. Support research, innovation, and policies that promote nature-based solutions. Use water wisely at home, every drop counts. Together, we can protect our water and our future. Let's make a positive splash. Science in action.